Now for this problem, we're looking at Khalid and the fact that he needs to earn tokens in order to, or he has to complete tasks in order to earn tokens, and he needs tokens to buy clothes in his real life game. So what I've done thus far is I've gone through the patterns and identified that for the number of tasks at 0, the pattern appears to be 0 times 2, which gives me a number of tokens earned as 0. After he completes one task, he gets 2 tokens. 2 tasks, 4. So that tells me that right away, for every task he completes, he's getting 2 tokens. So after 4 tasks, he should get 8 tokens. And you can see that in the pattern rule here, it's n, or a number of tasks completed, multiplied by 2, gives you the total number of tokens earned. Now you can create an explicit pattern rule to prove this as you double check your work. But in this question, it's asking you to create a graph. So what I would recommend doing in order to create a graph is you can use the number of tasks as your x-coordinate and the total tokens earned as your y-coordinate. And you build your graph. Now, when you're looking at the number of tasks, in this case for your x-coordinate, usually they will count by 1s, or they'll count by a common difference. And in this case it's counting by 1. So it makes it relatively simple when plotting along your x-axis, and your x-axis is always horizontal. Another important thing as you plot, you need to make sure that the space between your plotted points is exactly the same every time. Because if the space is different, that will affect the relationship line between total tokens earned and your number of tasks. So you'll notice here across the x-axis, I've skipped one line for each number. So I'm following the same pattern for plotting the points. Up the y-axis, for total tokens earned, I look up here and it seems to be counting by 2s rather than counting by 1s. So what I would like to do is count by 2s, but again, my plan is to skip every other, so I've got them spread out so I can clearly see my answer, because if they're too tightly packed together, then the height of my graph would be really, really short. It may only be this tall. And if the graph is only that tall and only that long, it may be really difficult for me to interpret a line on the graph as far as the size. So one thing I do recommend is if you're going to be building a graph, try and make it a reasonable size so that you can see everything that's going on, making it easier for you to interpret the work that's there. Okay, so next. Once we've identified or created our x and y coordinates and we've plotted our grid system, the next thing that we need to do is start to analyze the data in the table and see how we can take this information and convert it into plotted points. Well, as you see on this graph, there's already a graph line. And this graph line came from what? Well, how did I develop it? Well, I didn't just make it from thin air. I developed it directly from our table of values. So when the number of tasks n equals 0, that represents the x-coordinate. So along the x-coordinate, that means it starts here at 0. But the coordinate pair for the 0 is over here. So for every coordinate pair, there are 2 numbers. The first number is always the x value, and the second number is always the y value, whenever we look at coordinate pairs. That means for the first pair, it's 0, 0. And when we plot 0, 0 on the graph, it would go right here. Now how do we know it goes right there? Well, along the x-axis we start at 0, and do we move up and down at all for the y? If it's at 0, it just stays right there. So we put our point at the corner 0, 0. For the next coordinate pair, x is 1 and y is 2. So that means we start at the origin, or 0, 0. We walk one space to the right for x, and then it says y is 2. So we're going to move right from where our pen is 2 spaces up. 1, 2. And then we mark our second coordinate pair. you'll notice that point, it falls perfectly on the line. Now the reason it does this is not by coincidence, but it's because of the way I've designed and set up my graph. The most important thing here is try and have your numbers fall on the lines themselves, as opposed to in the spaces between. Because as you're building your scale for your graph for your x-axis, in this case it's very simple, but if the numbers don't count by the same common difference, you may end up having numbers that don't fall on the lines. You want to have as many plotted points on intersects as possible, and an intersect is the place at which two lines cross over. So this happens to be a nice intersect right there on the grid line, so it makes our plotted points even more precise. So 1, 2, again we've plotted it. Sorry, the next plotted point would be 2, 4. So again, starting at the origin, go 2 across. Now you probably think, but you just counted 4 lines. Yeah, but if you look at my scale on my x-axis, I went 2 across because there's my 2. Remember, because I skipped a line and then counted 1, skipped a line, counted 2. So that's 2 across and then 2 up. Well, I did the same skip counting on the top or on the y-axis. So 1, 2. Am I supposed to go 2 up? Yep. 1, 2. Or am I doing 2, 4? I'm doing 2, 4 this time. So it's 2, and then I have to go up 4. This is 2, that's 4. Again, on another intersect, boom. The next one is 3, 6, so 3 across, 6 up. Now, do I have to keep going all the way to 10? No. What I would recommend you do, once you have the first 3 plotted off of the origin, I would jump to the highest one if you can. The highest value or coordinate pair that you're able to get right on an intersect. Luckily for this assignment, or this activity, the highest one shown, 1, 2, 3, 4, and then 8, fits perfectly. Now it might end up being 10, 25, 10, 25, and that may fit perfectly on the intersect. And if it does, great, plot it. But the whole point is, you're going to be able to connect the dots as easily as possible, or create a line of best fit. So when you do that, you connect the first couple, and then make sure you can line it up with the last one that you've plotted, and then extend your line, ensuring that all those points are on the line, or at least the same number of points is above the line as you have below the line, so it becomes a line of best fit. But for this activity, the line's perfect. It happens to hit every point precisely where it needs to. So now to answer the question, first we have to describe the graph itself. So I've put a little description down here, and essentially it says that when we look at the relationship between the number of tasks completed and the total number of tokens earned, our graph line shows that relationship. And if you'll notice, it seems to be going up on an angle. This angle has a very special math name. It's called an increasing relationship. So an increasing relationship is a line that goes up on a graph when you're comparing two different attributes. So in this case, number of tasks, when compared number of tasks to the total number of tokens earned, that's an increasing relationship. Now visually, when you're using a graph, if you have a line that goes like this when comparing, well, that would represent a decreasing relationship. But the one that we're focusing on today happens to be an increasing relationship. Just know that for example. So here's a question that's really going to throw you. What would this be? Something to think about for later. Okay, let's get back to this question now. So if we read through this, we identify that it is an increasing relationship between number of tokens and number of tasks. That means as you complete more tasks, you earn more tokens. That's the relationship that we can clearly see in the graph. Now can we answer Khalid's problem? How many tasks does Khalid need to do to earn 16 tokens? The only way we're supposed to complete this is using the graph. So we have to use the graph. We need to know, in order for him to earn 16 tokens, how many tasks? Well, on the tokens y-axis, our scale only goes up to 12. We need to continue to add. So they're counting by 2's. So 12, and we've got 14, and then the next one is 16. So the 16 line, that's going to be the line that tells us how many tasks he has to do. So you'll notice I'm walking that across all the way to the relationship line, because the relationship line tells us the relationship between the total number of tasks and the total number of tokens earned. Once I hit that line, I can drop down straight right to the x-axis, and that will match and tell me exactly how many tasks have to be completed. Let me change the color. How many tasks have to be completed in order to earn 16 tokens. To work backwards, I can say, well, if he completes 7 tasks, and I go up this way, if he was to complete 7 tasks, how many tokens would he earn? Well, he would get 14. And for every task he completes, he gets 2. Okay, so if he completes 7 tasks, he gets 14 tokens. That means he only has to complete 1 more task to get 16 tokens. You'll notice that I've solved the question a different way and work backwards at the same time, using logical reasoning. So I hope this helps explain some of the nuances in a patterning assignment in which you have to use the graph to answer the question. If you really want to double check this, using the explicit pattern rule and solving it that way is another way of showing your solution. So I hope you've been practicing that too.